All right, let's get started on trigonometry. So, looking at trigonometry, it is the study of properties of triangles, properties of right triangles, and their functions and their applications. So a trigonometric ratio is the ratio of the lengths, so we're talking about lengths, of the sides of a right triangle. So what they have found out that for right triangles, you have these ratios that occur. So the sign for acute, for the smaller acute angles, not the right angle, of a right triangle that involves the lengths of your opposite leg. This will make more sense in a minute. And the hypotenuse. Okay. Often written as just the word sine. And I think it's in your calculator that way. Might want to dig out those calculators. Yeah, it's right there. So here they are on our calculators. And these up here, if you could see the yellow on mine or up here, those are the inverse properties. All right, so the cosine. The cosine also has to do with those acute angles because obviously, if you're right triangle, the other two are acute, just to make sure you understand, of a right triangle that involves the lengths of a leg and the hypotenuse, but a different part of that leg. So this one is your adjacent leg. And we're going to get through that in a minute. Hypotenuse. And on your calculator, it's written as COS. The tangent for your acute angles of a right triangle that involve both legs, written as tan, and this would be opposite and adjacent. Okay, so let's go and talk about that. So down here, I want you to make a right triangle. And I specifically want you to understand. So if I am talking about this angle, and we'll say angle A, B, C. Okay, go ahead and do that. The side opposite is BC. The side adjacent is AB. And maybe I should call these legs. And then AC is my hypotenuse. Okay. And again, I say this over and over again. Your hypotenuse is opposite of the right angle. It is the longest length. Okay. So you get to learn these ratios. So try not to make this more difficult. Okay. Easy for me to say, right? Sine is the ratio of your opposite leg. I don't want to say that. Opposite side to your hypotenuse. Okay. So if I was looking at A, and this is what they'll do. They'll give you a certain one. So what's opposite? CB. What's your hypotenuse is AB. Did I say that right? Opposite is BC. Okay. So if I said the sine of A, so I'm looking at that, my opposite is CB, and my hypotenuse is AB. If I was looking at B, again, my opposite is AC. my hypotenuse would remain the same, AB. Okay. All right, so now we are going to use numbers. So for A, my opposite here from A is 3. My hypotenuse is 5. Here for B, my opposite is 4. My hypotenuse is 5. Let's try this next one. So here's A. My opposite is 15. My hypotenuse is 17. For B, opposite is 8. My hypotenuse is 17. So those are all of your ratios. Okay. Let's talk about cosine. So again, its ratio is the adjacent leg over hypotenuse. Okay, so cosine, so you're just changing these to cosine, but my adjacent leg is the one that shares a side, shares a vertex. So for A, it can't be this because that's my hypotenuse. It's this one. This one is my opposite, so it has to be AC and then hypotenuse. For B, BC is my adjacent and AB is still my hypotenuse. Let's try it. So if I was looking at A, I would need my adjacent and then my hypotenuse. And you would simplify these, and we're going to punch these into the calculator anyway. So later on, let's just get used to writing them. So B, adjacent would be CB, which is 30, and over 34. I really should simplify those, but we're going to move on. Cosine of A, so adjacent, it shares that vertex. So that's 7, hypotenuse is 25. For B, what shares this? That's not the hypotenuse, it's the 24. Tangent are both of the legs. So opposite, adjacent. Okay, so here, opposite from A is CB. Adjacent is the one that shares the vertex, so AC. This one, opposite is AC. BC is my adjacent. Okay, let's look at this. Opposite of A, that's my 20. My adjacent is 15. For B, opposite is 15, adjacent is 20. Here, A, opposite is 21, so no hypotenuse at all. So 25 should not be anywhere here. 29 should not be anything here. So 21 over 20. For B, it's 20 over 21. So these are like the reciprocals of. Okay. So here we go. I have a little ditty that goes with this, sine, cosine, tangent. These are the things that you need to know. So let's find the sine of L, cosine, and the tangent of L, and then we'll do that of N as well. And write each answer as a fraction and as a decimal to the nearest hundredths. So let's start with the sine of L. So the sine says the opposite, which is 12, over my hypotenuse, which is 52. So let's simplify that. We'll go calculator, 12 ABC, 52. And I get 3/13. And then if I would divide that, change this to a decimal, all I'd have to do is hit fraction to decimal and round to the nearest hundredth, so 0.23. Cosine of L. Cosine of L is my adjacent, which is 39, over my hypotenuse, which is 52. See if that can be simplified. 3/4. Hopefully you know what that is as a decimal. Sine, cosine, tangent of L. Tangent is opposite, so 12 over adjacent, which was 39. Four thirteenths. Change that to a decimal. 0.31. All right. I know I should do tangent for n. Is that what it is? Sine, cosine? And then do the same thing for tangent. We're out of room here. Let's just keep going. Okay. I'm going to stop here so you guys can take a break, and I'll get back going.